But why is an imaginary number imaginary? So to answer that, I'm going to show you this one example. All right, let's take the square root of 9. And so to reduce this, we think to ourselves, well, what is one number when multiplied by itself equals 9? And it would be 3. 3 times 3 equals 9. So the square root of 9, you could also write that as the square root of 3 times 3. And because there are two 3's, we can reduce this and take out one of the 3's to get 3. So square root of 9 equals 3. And then another solution is actually negative 3, because 9 equals the square root, or 9 equals negative 3 times negative 3, because the negatives cancel out. So this expression is also correct. So square root of negative 3 times negative 3. And because you have two of the same number, you can remove that out of that expression, and you get negative 3. So square root of 9 equals 3 and negative 3. There are two answers to it. Right? Same thing if we did, let's say, the square root of 25. This equals the square root of 5 times 5. And because these two numbers are the same, you could take, this expression could get reduced to just 5. And same thing, another answer is negative 5 times negative 5 equals 25. And so because these two numbers is the same, you could take them out. You could take, it gets reduced to just negative 5. Right? So 5 and negative 5 are both answers to the square root of 25. But if I asked you, well, what is the square root of negative 9? Well, then you think to yourself, all right, what is one number that when multiplied by itself equals negative 9? You're like, well, the only way you could get negative 9 is you could have 3 multiplied by negative 3. But because these are two different numbers, you can't reduce this any further. So square root of negative 9 is just the square root of negative 9. There's no way to reduce it. So because there's no number when multiplied by itself equals negative 9, we can say that no number exists. It's imaginary. It's not of this real world. And so that's why we introduced this concept of an imaginary number, to be able to express this expression. So a way to do this with imaginary numbers, a way to reduce this expression, is to say, well, the square root of negative 9 equals the square root of negative 1 times 3 times 3. And then you see, okay, well, there's two 3's, so you could take the 3 out, and you're left with 3 times the square root of negative 1. And what did I say in the beginning? That I equals the square root of negative 1. And so we can just replace this square root of negative 1 with I. And so if you do that, we get the square root of negative 9 equals 3i. And that is the same expression.